This is a AQA Functional Skills Level 2 Mathematics Paper 1. That means it's a non-calculated one and you have half an hour to do it. The first question shows a scatter diagram. You can see the scatters, and it says that 4 of the points are labelled, and you can see A, B, C and D. Which of these points is an outlier? Remember, that's the one that doesn't follow the pattern. You can see here's the pattern very clearly, and you can see that C does not follow it, so that is the outlier. Part 2 says work out this calculation, so we're going to have to make sure we align our numbers very clearly. So we have 942,795. We're going to subtract from it 350,823. Okay, so that's the calculation we're going to do. 5 take away 3 leaves 2. 9 take away 2, 7. 7 take away 8 we can't do, so we're going to have to borrow. So we're left with 1 there, and we have 17. 17 take away 8 is 9. 1 take away nothing is 1. 4 take away 5, again, we're going to have to borrow, so that's an 8. We have 14. 14 take away 5 leaves us with 9. And 8 take away 3 is 5. So the answer is 591,972. Do take care, because 1 mark, so 1 little mistake would mean that you lose that mark, even if you know what you're doing. Brilliant. Question 3. And question 3 shows a frequency tree. We have 44 things. Some of them are red, some of them are blue. 20 of them are red, 24 are blue. The frequency tree shows information about 44 coloured items. One of the items is chosen at random. Work out the probability that the item is blue. In other words, this is the one we're interested in. And give your answer as a fraction in its simplest form. So the probability will be 24 things out of 44. And that would get you one of those marks. But now we must simplify it. And if you know your times tables, you can do it in one go. But I noticed that they both are even numbers, so I'm just going to halve it. Half of 24 is 12, and half of 44 is 22. And once again, they're even numbers, so I can halve them. Half of 12 is 6, and half of 22 is 11. Now, 11 cannot be divided by any numbers, it's a prime, so here we can leave it as 6 out of 11. And that's our answer, 2 marks. The next one says work out 19% of 150. Now if it were a calculator, we'd do one method, but this is a non-calculator method, so really it's easier to break it down into 10%, 5%, 1%, and if I do that I'm going to have several other 1%. And you might say, why am I doing that? Well, if I add 10 plus 5 I have 15, 16, 17, 18, 19, and that would give me what we're looking for. Working out 10% of any number is easy because you divide by 10, so 150 divided by 10 will give us 15. Half of 10 is 5, so half of 15. Well, it's an odd number, but if I halve it, I'm going to end up with 7, because 2 7s are 14, and a half, 7 and a half. Now, if I want to put 1%, I need to divide by 100, so I divide by 10, divide by 100, and I end up with 1.5. And obviously I can just repeat these 4 times. And the final step is to add it. So we have 5, 10, 15, 20, 25. Carry the 2. 5 and 2 is 7. 7 plus another 7 is 14. 15, 16, 17, 18. Carry a 1. 1 plus 1 is 2. Don't forget the decimal place. So 19% of 150 turns out to be 28.5. Show your workings, because if you show your workings, it means that they're more likely to give you marks even if you make a mistake along the way. Let's have a look at the next question. next question shows two parallel lines. It's not drawn accurately, but these little arrows show that they're parallel. We have several angles labelled, 115, X and Y. It says work out the size of the angle X and the size of the angle Y. Well, the first thing is we identified that these two angles are opposite, and on parallel lines you have vertically opposite angles, they are the same. The other way to think about it is this is an obtuse angle and that's an obtuse angle, so they match. So X I can write down straight away is 115. 115. Okay. Now, when you come with parallel lines, whatever happens in this intersection will also happen in this intersection. So in other words, we know that one there is 115 because top right was 115, so top right this point will be 115. That is a straight line, and if you have a straight line, you know straight lines add up to 180. Take away 115, and that will give us what we're left with. Now you might want to put 115 below here and do it that way, but I'm going to count upwards in this case. So another 5 would make that 20. I have here 80, so to get to that it's going to be 60. So it's going to be 65. I can check 5 plus 5 is 10, carry 1, 6 plus 1 is 7, plus that one there is 8, and then we have the other, so that looks fine. That's going to be 65 degrees. So we write our answers in the section provided. Lovely. Question number 6. And question number 6 is, question number 6 is section B. And section B are those longer questions. And here we have a chart, and they tell us that Joe has a baby. The baby is called Ella. The graph shows, or is used to convert grams to ounces, grams and ounces, and there's some numbers along the bottom and on the vertical axis. At birth, Ella weighed 3.5 kilograms. Did Ella weigh more than 8 ounces? Here we have a conversion that says 1 pound is the same as 16 ounces. You must show your workings. So the first thing to notice is if we want to convert between grams and ounces, we need to be in grams, and she is in kilograms. So the first thing I'm going to do is change 3.5 kilograms into grams by multiplying by 1,000. If you multiply by 1,000, you'll end up with 3,500 grams. So now we can look for 3,500 grams. Sorry about that, I'm just going to push it up so you can see what I was actually doing. I apologise. There we are. Okay, so now we're going to look where 3,500 is. 3,500 is there. It might help you if you get a ruler and actually mark the line to make it clear what you're doing. So here we have that line. Draw your line until it intersects or crosses the line that's provided, and then drop it down. So when we drop that down, it's going to come out there. Okay. So now we can read the axis, and it says 120, this is 130. We have 5 boxes, so that means we're going to be going up in twos because we have 120, 122, 24, 26, 28, 30. So it's going up in twos. In other words, that is 124. So that point there is 124 ounces. So we can write down that Ella, okay, Ella weighs 124 ounces. Now that's important because we want to compare, or we want to find out whether Ella weighs more than 8 pounds. So what I'm going to do is I'm going to change those pounds into ounces and compare her weight with what they're saying. So let's see. So to do that, if 1 pound is worth 16 ounces, I need 8 lots of 16. Now if you don't like doing multiplications, you could just add 16 8 times and the answer will come there. But if we have here 8 times 6, that's going to be 40, sorry about that. 5 lots of 8s are 40, and another 8 will be 48. Carry 4. 8 times 1 is 8, plus 4 is 128. So that's how many ounces is the same as 8 pounds. And it says here, did Ella weigh more than 8 pounds? That's what she weighed. This is what 8 pounds is worth. And so the answer here is no, because she weighs less than this number down here. Okay, hopefully you can see it there. So what I'm saying is that's what she weighs, that's what 8 pounds is, and when you compare it, she weighs less than that one. So the answer is no, she doesn't. Let's go on to part B. And part B says, here are the weights of 7 babies that are born on the same day as Ella. They're in kilograms. The mother of Joe says Ella's weight is 3.5 kilograms. Well, we know that because that's before. And she says it's more than the average weight of all the other babies. And Joe says, no, well, it kind of depends on what type of average you use. Show that Joe is correct. So here what we have to do is calculate the different averages and see or show that it's correct. So the first one I'm going to do is I'm going to work out the mode. And the mode is easy because the mode is one that repeats the most. And you notice we have lots of 4s here. So the mode is 4 kilograms. I'll then work out the median. And the median is the middle number. And so if we cross off that one, that one, that one, that one, that one, that one, we have 3 numbers in this side, 3 numbers on that side, so the middle one is 3.6. I could do that because they were already in order. Okay, you notice they're going from small to big, and so 3.6 is the median. Now the last one I'm going to do is work out the mean, and that will take a little bit more effort because we have to add all these numbers together. To do that, you might want to put them in a column, lining up the decimal dots. And then we have 4. If it helps you, you can say 4.0. You don't have to, you could just line up, but that might help you not put the 4 in the wrong place. And when we go adding, find easy pairs to add. And so what I'm going to do here is I'm going to say 3 plus 7 is 10, 10 plus 5 is 15, plus 6 is going to be 21. Carry 2. 2, 4, 6, 8, 9, 10, 11, plus 5 is going to be 15, plus 4. Sorry about that, that made a mistake here. 2, 4, 6, 8, 9, 10, 11, 11 plus 4 is 15, 15 plus 4 is 19, 19 plus 4 is 23. So the total is going to be 23.1 divided by 7. Why 7? Because there were 7 babies there. Once again, you need some space for working, so I'm just going to make some space down here for working. So I'm going to have here 23.1 divided by 7, and we say, does 7 fit into 2? If we just have the 2, no, because there's only 2 things, we can't take 7 things out. So now we say, does 7 fit into 23? And it does, because 3 lots of 7 is 21. So 23, yes we can. So there are 3 lots of 7. But that means we have a remainder of 2, because going from 21 to 23, we have a remainder of 2. So now I said, does 7 fit into 21? Yes, we know, because here's the calculation, and we know it fits in 3 times. Now, because there is a decimal point there, we're going to put the decimal point there. So the mean turns out to be 3.3 kilograms. And so what we wanted to show was that it depended whether Ella was more than the average, depending on which average, because she is clearly 3.5 is bigger than 3.3, but it is not bigger than 3.6 and it's not bigger than 4 kilograms. So we've shown that what Joe was saying was correct. You can write a little sentence explaining that if you want to, but I think there's probably enough there to make it obvious what we're doing. Okay. Let's have a look at 6C. And 6C is the last question of section B. And here it says, Joe sees this special offer on nappies, 1/3 off the usual price. Nappies come in a pack of 25 and the usual price is 6.75. So that third off refers to this number here. Joe normally buys the nappies at a cost of 21 pence each. How much will Joe save per nappy by buying this pack? You must show your workings. And if you look all the way down here, the answer comes out in pence. So it really means we're going to work in pence for this question. So when I'm up here, I'm just going to write that now as pence. So £6.75 is actually 675 pence. And then that way I won't make a mistake about forgetting to do that. Okay, so what we need to do is we need to find out how much it costs for one nappy using this offer, and then compare it to 21 to see how much she saves by doing that. Okay, so first things first, let's find out what a third off is. And so to do that, we're going to say a third off 675. Okay. Now when you do that, that actually means you're going to multiply 1 times 675 and you're going to divide by 3. So like before, you might want to do a little bit of working out separately. So we have 675 and we're going to split it into 3. Does 3 fit into 6? Yes, it does twice because 2 lots of 3 is 6. There's no remainder, so we can just look at the 7. Does 3 fit into 7? Yes, it does twice because 2 times 3 is 6. But because we had 7, we have a remainder of 1. Does 3 fit into 15? Yes, it does. It fits in exactly. So in other words, if we're having a third off, we're going to save 225 pence. So we're going to say instead of paying 675, we're going to save 225. So we're going to do a subtraction to see what she'll pay. So 5 take away 5 is nothing. 7 take away 2 leaves me with 5. 6 take away 2. So 450 pence. And that is for a total of 25 nappies. But that is not what we want. We want the price for one. So we're going to have to split the 450 into 25. So we're going to do another division. Now in this case, you might actually prefer to count upwards, going 25 plus 25 plus 25 and see how many make 450. But I'm going to do it this way. Does 25 fit into 4? No, it doesn't. Does 25 fit into 45? Well, yes, it does, because we know that 1 lot of 25 is 25 and 2 lots of 25 is 50, and we don't have enough here for 50, so it just fits in once. Okay, what's the remainder? Okay, it's going to be a bit tricky because we had 45 take away 25, so the remainder is going to be 20. So I'm going to have to fit in here 20. So now we have 200. How many 25s fit into 200? Well, you could count upwards and find out, but what it turns out to be is that it's 8 lots of 25, because 25, 25, 25, 25 makes 100, and then you need another 4, so or doubling it, so that will make us 200. So we need 8 lots. So in other words, one nappy costs 18 pence, and they want to know how much she will save. So she normally pays 21 pence, and now she pays 18 pence. And so she's going to save, or you could count upwards, couldn't you? You could go 18, 19, 20, 21 to find out that the answer is 3 pence. But now I've started out, I might as well finish. So I'm going to have to borrow 1 from there, so 11. 11 take away 8 leaves us with 3. 1 take away 1 leaves us with nothing, because, okay, so in other words, 3 pence. But in this case, it was actually easier to go 18, 19, 20, 21 to get there. Brilliant. So we've got there. Well done. That's the end of that paper. Hope it's been useful, and see you next time.